But yeah, let's get into it. Before we get started, anybody have questions? Is there anything outstanding? I think there's a few regrade requests that I still gotta handle. But other than that, anything that hasn't been addressed that needs to be addressed in this class? Okay. We talked about project stuff before. One thing, I had a question related to this anyway. So worth mentioning to everybody, the team meeting forms. One, make sure you're filling these out each week. I'd say even if, I don't want to say that, but fill these out each week, and you can fill these forms out more than each week. Like, they don't have to exactly correspond with meetings. So don't think we had a meeting. Well, when you have a meeting, you should fill out the form. But don't think I want to fill out this form again, but I got to wait till the next meeting. If you just want to put some ratings, like maybe between meetings, a teammate really pissed you off or something, or they forced push to your main branch in your repo and destroyed everything, and you want to make sure that's known, to me at least. Feel free to fill out the form even if there wasn't a meeting attached to it. If you want to fill out the ratings, like, you don't have to fill out what I did last time, what I'm going to do before next time, but if you just want to fill out the ratings in extra time, this is especially applicable at the end of the semester. Like, sometimes students, believe it or not, don't do anything for the presentation. Like, everybody agrees that they're going to prepare their section of the presentation, and one person just doesn't. And you're not going to have a meeting after the presentation to report about it. Feel free to fill that out again. These don't have to correspond to meetings. You should definitely have one for each meeting, a submission for each meeting, but you can have additional submissions. I review those manually at the end of the semester after projects are graded. I go through all of the submissions for the entire semester for everybody and decide what individual grade adjustments need to be done to the project. So I'll take any information that I can get, anything that you want me to know that you think will be helpful and informative during that process, let me know through that form. And if there was an issue that you just don't want me to know about, don't tell me. You don't have to report that. You can, some teams do the typical, just give everybody straight 10s all the time. That's fine. If you don't have an issue, I don't have an issue. There are rare cases where I do, even if you give all 10s to all of your teammates, I'll still go in and do an individual grade adjustment if I see it necessary. Sometimes I will override that, by the way. So the final decisions are mine. I don't do any mathematical thing like average all of the scores that you gave throughout the semester, and that's what everybody's grade is adjusted using. I know other professors do that, and I know that's a lot less work. I put a ton of effort into processing all this stuff manually and making the decisions myself. But I don't like doing the mathematical thing, because then everybody lies. They all say everything was great. So if you do give somebody a bad score one week, that doesn't mean their grade is going to be lower. But it helps me make my decisions at the end of the semester. So anyway, somebody asked about that, and I want to make sure the answer is there for everybody. Anybody have questions about the projects? Are they going well? Have they been started? Yeah. Yes, it's been started, or you have a question? Yeah. Do I look at? Yes. So my main decision, so here's my process when I review at the end of the semester. I'll glance at the ratings, and I'll see if there's a red flag. If something catches my eye, like an entire team is saying this one teammate did nothing, then I'll go into the repo and see if I can verify that. If I can't verify, if I look and that team member has a lot of commits and they're not like clearly broken commits or commits that are just cut and paste from the internet, if there's no red flags that I can verify, then I'm not going to make an individual adjustment. I'm not going to make a grade adjustment. But if I do go into the repo and I see quite often 0 commits from a specific team member, that's an easy decision. Like, that member's probably getting a 0 on the project, and the points that they would get are going to be distributed among their teammates, because that's fair. I think that's fair. Did you have a follow-up? How would I know that? I would click on the commit. Like all that information's in the repo. Like it's not like I'm going to the contributors graph and just basing my decisions off of that. I'll check that. That's my first check just to see, just to start building the case. But I'll go into the commits. So sometimes students won't show up on the contributors graph because they never link their email. They never link their GitHub account to their commits. So I have to manually go through the commits, look for their actual name next to their commits that is not associated with a GitHub account, and then actually look at those commits to see if they're meaningful or not. It's a process. It's a pain. That's why I kind of like when y'all just say, everything was great, because then I don't do anything. But there's always like 5 or so teams where I got to go in and really investigate and see what happened. So don't worry about getting screwed out of your points if that's the concern. Because I will have it sometimes where a whole team just doesn't like one particular member, so they give them bad ratings even though they're a good dev. They give them bad ratings because of personal issues. So I want to make sure that doesn't get in the way. I'm not changing grades based on personal issues. It's not how it works. So I got to adjust against that. And then sometimes the ratings will be too high. They'll be too nice. Again, usually for personal reasons. They like the person, but they did absolutely nothing. Sometimes I'll still go in and change their grade because they didn't get what they should have gotten out of the project, and they had their teammates do all the work. That's quite rare, though. But I have done that in the past. Part of the reason I do that is if I just do the numeric average and that's your grade, you're going to be fighting with each other once grades are out. And who gave me a bad score? Like, sometimes it's just me. I do it. I'm the bad guy. And then you don't have to lose friendships over it. Any other questions about anything at all? Oh, yeah, the commit yeah, I see the commit messages when I do these investigations. I expect them to be shitty. There's not much that can surprise me in your commit messages. You don't think you're worried about them being shitty? I mean, unless as your commit message you said, F you, Jesse. I don't know what else could be in there that I'd care, that I'd be like, that I'd be really offended by. Is that what you did, Cole? All right, homework 4 is out. Let's talk about homework 4 real quick. Oh, yeah. Does it have to be signed? What do you mean? Oh, your commit? I mean, no. But, like, people can't steal your commits, so I'm not too concerned. Your teammate would be making commits on your behalf. Like, if they're going to do that, like, I'm not going to stop it. Of course, they don't have to be signed. I just said that I'll check commits, like, just with a username, not even affiliated with a GitHub account. I think you're going to be fine. If you're worried about something like that, you're fine. It's the students who haven't done anything with the project, the students who don't show up to your group meeting, like those are the ones that are going to get hit by this stuff. If you're actually working with your team and making commits, you're not going to get hit by it. Yeah. Oh, and I'll wrap up one more thing with that. With the team meeting form, if you don't fill it out at all, like, I'm just going to assume the worst. Like, the easiest decisions that I can make are an entire team says this one person did nothing, and that person did not even bother filling out the team meeting forms throughout the entire semester. They have 0 submissions the entire semester. At that case, I might not even look at the commits. Like, at that point, you're not doing anything you're supposed to be doing. You're not even trying. It's pretty easy. I might go all the way down to a 0. Well, maybe I'll take a peek at the repo just to confirm what I know I'm going to find, but that's an easy call. If you don't even bother telling me how the meetings went, I do weigh that in my decisions, if you fill out those forms or not. All right, so homework 4, and a lot of you that won't even apply to. I shouldn't have spent so much time on it. A lot of that won't apply to you. Just fill out the forms, work on the project, be a good teammate. You won't have to worry about any of that at all. But if you have a teammate doing nothing, I got you covered on that. Just let me know, give me the information I need, and I can change the grade. And give you the points. It's a zero-sum game, but you can't go over 100%. So like if you got an 80 on the project and one teammate did nothing, I'm going to give their 80 points to the other members. You're all going to get hundreds. So just keep all that in mind. All right, so today we're going to learn how to do Objective 1 of Homework 4, the visit counting cookie. This is something that it's not too hard to do. This is something that I just had to find a home for cookies, and I did it in a just-in-time way. So when we talk about authentication, you're going to have authentication tokens to be able to stay logged in, and those tokens are going to work through cookies. So we have a need for cookies, so we're going to learn about cookies today and have Objective 1 just kind of warm up how to set a cookie and read a cookie. And spoilers, it's all through headers. This is another case where if you have that generic header parsing code that you wrote for Homework 1 that you've been using all semester, you're going to use it again here, and this cookie business is going to be almost no extra work. You're just going to use your header code that you've already written. So we want to set a visit counting cookie to count, as the name implies, how many times a specific user visited the page. So a user goes to your page, they'll see visits 1, or whatever you put on your front end to show the number of visits. They hit refresh 3 times, and it should say visits 4. Visit counting cookie. They close the page, close the browser, reopen it, go back to your page, it should say 5. Fairly self-explanatory, right? That's what we want to build today. We're going to get to authentication. Tokens, so you stay logged in. Same thing, if you close down your browser and reopen your browser, we expect to still be logged in the sites that we're visiting. We're going to do that with authentication tokens, which work through cookies. Once we have authentication, instead of generating random usernames in our chat app, we're going to actually take the user's username that they're logged in as and have verified usernames in our chat. Those cross-site request forgery tokens that I said when you did them for Homework 2, they didn't really work. Well, we're going to make them work because we're going to associate those tokens with an account, and you have to be logged in with that account that was served the token in order to use that token. And that's going to make these cross-site request forgery tokens very, very strong. And finally, HTTPS. This is a very different objective than all the rest of the ones for the course. This one, there's not a lot or any. I don't think any code for this objective. It's all configuration files. It's all setup of Nginx and Docker Compose to be able to get HTTPS. We want our encryption. We want a secure connection. We're finally going to get there. And the last objective of the last homework, we're going to get our HTTPS. We're not going to get our green lock because we can't get a certificate for localhost. You'd have to get a domain name and everything. And I forgot to add to the project requirements that you need HTTPS. So unfortunately, you're not required to have that green lock. But I would recommend to do it, and I'll show you how to do it for your projects. When you deploy your project, you're getting a domain name for that. Then you can get a certificate to secure that. Our apps, we're going to run them on localhost. You can't get a certificate for localhost. That all makes sense when we get to all that content. But we will have HTTPS with a warning that says, are you sure you want to do this? This is a self-signed cert. We will get that level of security. So with that, let's get into cookies. We need cookies for a little bit of background before we dive into it. And even with that long intro, we still might actually end a little early today, which I'm fine with. I think we could all use a little bit of a short day. Oh, I missed the conversation on commit messages. I'm curious what they are now. I might go look at commit messages. No, I don't have time for that shit, but I might go look at commit messages just to see what y'all are talking about. Oh, why is this auto playing? Okay, HTTP is stateless. I've said this a bunch of times. It probably hasn't really... Actually, I don't think I said it a bunch of times. But regardless, HTTP is stateless. It's a request-response protocol. When you get a request, you've written lots of code that handles HTTP requests in your server. And when you get those requests, you only use information that's in that request to generate the response. You don't get the request, do a database lookup, and then depending on that, actually you do that now, but based on that database, what do I want to say here? If somebody sends you the same request, if two people send you the same request, you're sending them the same response. There's no state that says, okay, oh, this user sent me a request. Well, I'm going to send them a specific response. This user sent me a request, the same exact identical request. I'm going to send them back a specific response. That does not exist in HTTP. It's stateless. The only information you have to go off of is what's contained in that request. But we would like state. Like, state is a nice thing to have sometimes. Like, if I visit a social media site, I want my feed, not your feed. I don't want a generic feed that everybody gets. I want some personalized information in my web requests, even if I'm sending almost the same request. So we are going to change these requests on a per-user basis. And we're going to use that through cookies. So cookies are going to give us the idea of a state. The idea of a state by having the user send certain information with each request, and we're eventually going to use these for authentication. When you do something on an app that requires authentication, you don't want to type in your username and password every single time. That'd be a pain. We're going to use cookies for authentication as well to keep you logged in, and we're going to send that information on each request through cookies. So we're going to set a cookie. You've probably done this before. I think the time frame's about right that you would have done this in 199. I think you would have taken Alan's module and done this, where you set a cookie client side. You wrote JavaScript on the client that ran in the browser that set a cookie, and then that cookie was sent on every request. Every time you made a request to the server, that cookie was attached to that request. We're going to do something similar, except we're going to do that server side. The server is going to tell the client to set a cookie, which is a thing that we can do, and then the client's going to set the cookie, and then each time they send us another request, we would expect to see that cookie in their request. And we want to talk about all the mechanics of how that works. So for your objective 1, they're going to send us a request. We're going to get a request. We're going to check for a visits counter cookie. If it doesn't exist, we're going to set it. If it does exist, we're going to increment it. And in either case, whatever we're sending back as that cookie value, we're going to send in the HTML using our HTML templating. We're going to say, you visited this site this many times. And this all works through headers. Cookies are 100% headers. Since they're headers, cookies are limited to ASCII. We know headers are limited to ASCII. Cookies are in headers. Cookies are ASCII only. ASCII only in cookies. And there's 2 headers that we're really concerned with: set cookie and cookie. These are the only 2 headers that we need to think about when it comes to cookies. Set cookie, that's the one we're going to send in our HTTP responses to the client. We're going to set a set cookie header, and you guessed it, it's going to tell the client to set a cookie with whatever values we give it. And we're going to look at the format in a few slides here. And then cookie, this is when the client sends us a request, we're going to expect a header named cookie that's going to contain all the cookies for that user after we tell them to set a cookie. Before we tell them to set a cookie, like any requests you've seen so far this semester, there hasn't been any cookie header unless you had some other app running on localhost which set a cookie, or you did your 199 which ran on localhost and set that cookie and it never got cleared. You know, you might have a cookie in there from something else, but not from your server in this semester would you have a cookie set. So we wouldn't really expect that header to be set yet, but once we do set a cookie, then we are going to expect that header to be set. We're going to read that header's value to see what the cookie values are for that particular user. So the set cookie header, this is what we're sending to the client in an HTTP response. And the syntax is key equals value. We've seen this syntax all the time. Set cookie, key, value, key, value. This header, if I send this header in an HTTP response back to the client, I expect them, well, the browser's going to do all this. Obviously, it's all in the background. The users don't have to think about this. It's going to set a cookie named visits to the value 4, and then the next request from that user, I would expect them in their cookie header to have a cookie named visits with a value 4. And mechanically, that's how cookies work. Obviously, there's a bit more to talk about, but that's how cookies work. We're going to send a set cookie header in the response, and then they're going to send us the cookies back in the request. We can only set a single cookie with set cookie. So this is one thing that if you took my advice and did this header parsing, that header parsing might break if you used it client side. It's a caveat, but it's not something you're going to run into in this semester. But if you want to set multiple cookies, you can send multiple set cookie headers, and duplicate header names are allowed. It's not strictly a set of key value pairs where you can't have duplicate keys. You can have multiple headers with the same name. It is allowed by the protocol, and if you want to set multiple cookies, you actually will do that. You have multiple set cookie headers with each of the cookies that you want to send. So if you want to set 5 cookies in one response, you have 5 headers all named set cookie in that response. Perfectly valid. So if you're putting things in a dictionary, like I always recommend, that wouldn't work on the browser side if multiple cookies are being set. I'm not aware of another use case where you would want multiple headers with the same name, but this one definitely does come up. Yeah.
I think you just answered that question. I was going to ask if you had ever run into a server-side issue where a browser sent multiple headers.
Yeah, no, I haven't personally. It is allowed by the protocol, though, so technically it can happen. Technically, it's a bug in what I recommend with header parsing in this class. It's not something you'll run into in this class, for sure. But yeah, it is technically possible. So if a browser decided to do that, if a browser is doing that, it's probably like you're building an app. It's probably your front end. So you'd have to do that by design. Like I haven't seen a browser just on its own do that. And since you control front end, back end, you just either wouldn't do that or protect against it. Unless your server completely breaks, because the client can control their own headers. And if they know that your server just crashes, they're going to send you a DDoS attack, or just a DOS, not a DDoS, but a DOS attack like that. They're just going to send you multiple headers with the same name and break your stuff. But other than that, if it doesn't actually break things, then it's not that big of a deal. Because presumably your code would just replace the first one that you read with the second value, and you would just get one of the two. You'd lose information. So when you get this cookie header back, and you have multiple cookies, they'll be separated by a semicolon. Other than that, it's the same format that we set the cookies in. So you're going to have multiple cookies by the end of homework 4, by the end of objective 2, actually, you're going to have an authentication token as a cookie and the visit counter as a cookie. So you're going to have multiple cookies. So in the cookie header, which is singular for what it's worth, even if there are multiple cookies, you're going to have those multiple cookies separated by a semicolon. So you get the value, separate them by semicolons, trim any extra white space, split on equal signs, and then get the values for these cookies. Which is, I think you'll all agree, trivial parsing compared to what you've already done in terms of parsing, like parsing multi-part forms. You made it through that. You can parse this in your sleep. Yeah. This is when the browser is sending it to us. Was that your question? Yeah, when the browser is sending, because this would be, in this example, we would tell the browser to set a cookie named ID and a cookie named visits. And then when they send us requests, we would expect both of those cookies in one single cookie header. Whereas like when we have to set the cookies, we have to use multiple headers for each, one for each cookie we want to set. But when we get the cookies back, it's all one header separated by semicolons. The reason we have to use multiple headers if we want to set multiple cookies is because it's not just a key value pair. We can add directives to a cookie. This is extra information attached to that cookie that gives it more information. There are a few, comprehensive. We're going to talk about all the directives, I believe. I don't think I skipped any. But we're going to talk about these directives. So when we want to add directives, we've seen this syntax before too. We're going to add a semicolon to separate any directives and a semicolon to show that we need a directive. This is the same syntax we use to say char set UTF-8, same syntax. We had our content type. We would say something like text/HTML, semicolon, char set equals UTF-8. We have extra information to attach to a header. We're going to have semicolons to separate any extra information. So we're going to do the same thing here. And then if we have multiple directives, separate them by semicolons and add multiple directives at your will. First directive we're going to talk about is expires. This is if you want to specify an exact moment in time. Well, nobody's going to call me out on that, right? There's no such thing as a moment in time. But if you want to specify a specific second that you want this cookie to expire on, you give it an expires time. Give it a timestamp, and then that's when this cookie is going to expire. When a cookie expires, the browser is going to stop sending that cookie on subsequent requests. That's the browser's job, is to enforce the expiration time. Now, the browser doesn't have to enforce that, but they all should. All the major browsers will, is enforce this expiration time. Then that cookie won't be set. We'll get a request from that user without that cookie, and then we'll treat it as a request without that cookie. We'll give them a new cookie, refresh, log them out, whatever needs to happen. Yeah?
Why is it GMT time?
It's just the way it is. Sorry. Why is it a GMT time was the question. It's just, it's in the RFC. That's just the way. It's the way. It's the only way. Sorry.
Is it GMT like a thing commonly used for like computers and stuff?
Yeah, so it's, oh, I don't want to, the mic, yes. Thank you. Yeah, I've been using this thing. I feel like a DJ. No problem. Have a good day, Mike. All right, here we go. Everyone still hear me? Cool. All right, that's just the way it is. I don't want to overstep my knowledge, but I believe this is just a format to specify a Unix timestamp. You take a Unix timestamp and then convert it to this information, and then GMT is just grand median time. I'm just strictly guessing, but it's like the time over in London or something. Whatever the time zones, whatever the zero time zone is, which I think is somewhere around London. I believe. If I'm completely off base with that, somebody can call me out on it. But I believe that's what's going on with this. So you would have some library to take your Unix timestamp or whatever you want and convert it to this timestamp format, yada yada. Or you just use max age like a regular person. So with max age, you're just going to specify the number of seconds after the cookie is set that cookie should expire. 3600, I'm going to have this expire in an hour. Because that's usually what we're concerned with. If you're having an expiration time, you probably computed that expiration time by saying, okay, I'm setting it now, I want to add however much time, and then have a timestamp. That's usually what you're doing. Maybe you have an application where you want everybody's cookies to expire at a particular time. If that's your use case, fine. If not, max age. Just hit it with a max age and make it simpler for yourself. Just number of seconds that you want this cookie to be alive. If you want it to be a year, just 365 times 3600 times 24, thank you. Times 24, and then set that as your max age. Yeah.
Is this where websites like kick you out if you're at like what is it? If you're not doing anything for an hour, or how do they?
I think that's front-end JavaScript. The question is this how sites kick you out if you're not active for a while? I believe they do that just with some front-end JavaScript that's counting your inactive time and then reacting to an event. Like if you do anything on the page, it'll react to that event and restart the clock. I believe that's how that would work. Because the cookies are only checked when you send a request, so it wouldn't be able to do it by cookies because it would have to wait for a request and then check that, which I guess it could do if it's polling.
But it would be really inefficient, right?
Yeah, but it would be inefficient to send a whole bunch of polling requests just to check the timeout. I would imagine that happens in JavaScript. If you don't use either of these, you're going to get what's called a session cookie, which is not what we want for, at least for the homework, and usually not what you ever want. Session cookies will be deleted when you close the browser. It's only for that browser session. If you don't use expire or max age, you have a session cookie, and that cookie is going to be deleted. So in our testing procedure, we specify close the browser and then reopen the browser, and then make sure your visit counter and your auth token didn't reset. That's to make sure that you used one of these two. I don't care which one you use. Probably max age would be better because, I don't know, you could use either one. You could use this as long as you set the date to more than like a few weeks after the deadline, just to make sure we don't have issues during grading. But use one of these two, or else you got a session cookie. Session cookies are bad. If you're using that for an auth token, every time you restart your browser or restart your machine, you have to re-log in. That'd be painful. We don't want session cookies, unless that's your specific application. Another directive is the secure directive. If you have the secure directive set, that cookie is only going to be sent over HTTPS connections. And that's all I want to say about that one. So usually you want to set this for auth tokens. You don't want somebody accidentally sending it over an HTTP connection. Then it's out there in the plain text, out there in the air. Anybody can grab that packet out of the air and read your authentication token, which is bad news. So secure. I don't have this requirement in the homework because you can't use it until Objective 5 after you have HTTPS. But you would set this for your, at the very least, your auth tokens or any cookie that has any sensitive information at all. You'd want the secure token or secure directive. HTTP only is this cookie can only be read. Can only be accessed through HTTP requests. Specifically, it can't be accessed through JavaScript. So if somebody's able to inject some JavaScript into your browser, somebody attacks your site and injects JavaScript, or somebody downloaded a risky extension and installed that into their browser, none of that can access this cookie because you can't access it through JavaScript. You can only access it through HTTP requests and responses. It's only sent with HTTP. So it gives you a little extra security that people can't access that cookie. The end users can still access the cookies. You can go into your cookies tab in your browser and edit any cookies, read any cookies. You can do whatever you want with your own cookies. But this limits attackers that are trying to remotely attack you from stealing your cookies because they won't be able to go into your browser console and read your cookies. They can't do document.cookie, which prints out all your cookies to the screen. They can't do that. Path is one that I don't find particularly useful, but it is used out there, is to only send the cookie for specific path prefixes. So if I have a section of my page, if you have a very large site, I guess this could be useful, but why not just send all the cookies all the time? What are you really losing? But there could be situations where you would want this, where only one specific path of your domain you want those cookies to be sent. So if I have a /chat path, and I only want these cookies sent on that path, I would set the path directive to be able to only send that cookie on those paths. SameSite, which can be lax, strict, or none. This is going to set the same site rules, I guess, and how you can access this with third party. So with strict, this cookie is only going to be sent on first party requests. That means it's only going to be sent on request to the domain that set the cookie. So if I set the cookie from localhost 8080, it's only going to be sent to localhost 8080, and when attacksite.com wants to request that cookie, sends a request to my server through that user's browser, like they make an AJAX request to your server, it's not going to send it to that host because that's not the host that set the cookie. Lax means this cookie is sent on third-party requests, but only when you're clicking a link navigating to that page. So with strict, the cookie's not set on that first initial page load from another domain. Lax is the default setting. And then none, the cookie's always sent no matter what. We're shipping this cookie all across the world to anybody who wants it. Everybody can access this cookie. And there's one more restriction. If you use none, you have to use the secure directive. You can't use none without secure and just send it in plain text across the world. For whatever reason, the protocol won't allow it. Now, all of these directives are enforced by the browser. So the same things apply that applied to the cores discussion, the cross-site attacks, the cross-site request forgery. These policies are all enforced by the browser. So if the browser isn't doing its job, if the browser's out of date, cookies have been around forever, so it'd be hard to have a browser so out of date that it doesn't have all the cookie directives. But it's possible. Maybe somebody has an experimental browser. Bless you. Some of these might not be completely enforced by the browser. I already mentioned this, but cookies can be set. I don't think I use cookies on this page, but I should have some set, I think. Anyway, this is where the cookies would be. But they're... Oh, I can still prove my point here without going to a new site. Well, I'm not going to bother. But you can set cookies. You already did them in 199, so I'll just refer to that. You can set your own cookies just by typing some JavaScript into the console. You can set your own cookies. So when you're writing apps, keep in mind that your users can set their own cookies. You're not just going to get the cookies that you told your users to set. You're not just getting those cookies. You could be getting any cookies, and they can change the values of those cookies. So don't expect that the value that you get is legitimate. You should still be verifying to the degree that you can that cookie is legit. Being very secure about how you set cookies, knowing that users can change those cookies. So for example, if your auth token is just your username, anybody can just change the value of that token and become any other user. So we want to make sure auth tokens are not predictable. We'll talk about that more when we get to auth tokens. But keep in mind that your users can set those cookies. I don't think transfer students usually take 199. Yeah, that's right. Transfer students don't take 199. So if you didn't take 199, if you didn't do that, You can type JavaScript code into your browser or put JavaScript code in your .js files that you're sending to the front end and set cookies on the front end. You don't have to use these HTTP headers sent from the server. The client can also set their own cookies. They have full control over their own cookies. And in 199, our students just cut and paste Alan's code anyway. They don't understand it to any more degree than I just said. So, unless you've done it before, a lot of students just cut and paste. All right, and we'll end a little bit early. Have a great day. I'll see you all Wednesday.